Okay, today's lecture is Friday, December 5th, and it's lesson 2.5, day 1. The assignment is page 322, 10 through 24 evens. Now, we've had a lot of talk about what zeros are, and I've told you that if you have a fourth degree polynomial, you're going to have 4 zeros, or 4 x-intercepts. Now, basically that's kind of true. You're going to have 4 answers, but some of them are going to be real number answers, and those real number answers you're actually going to see on the graph as x-intercepts, but you might have complex number answers. And when answers exist in the realm of complex numbers, you actually don't see them. So, today we're going to do a little bit of both. You're going to do examples, just like yesterday, where we have real number answers and complex number answers. So how do we find these answers? Well, the first step, it says, make a list of all the possible rational zeros. Rational means either whole numbers or fractions. So how in the world are we supposed to know that? Well, here's the thing. There's something called the rational zeros theorem, and it's long and it's tedious and it takes about 10 to 15 minutes. Now, do I ask you to do that? Absolutely not, because I think it's frankly silly. So instead, what we're going to do is we're going to cheat just a little bit with our graphing calculators. So how are we going to do that? Well, the first thing we're actually going to do is enter the function into our graphing calculator. So I have x to the third plus 8x squared plus 11x minus 20. Oh, oops, I should have done that. There we go. All right, so if I graph that, and I zoom in on that, let's take a look at this graph. Here's 0. It looks like we have 3 x-intercepts. One at positive 1, one at negative 4, and one at negative 5. So here's what we're going to do. We're going to cheat just a little bit, and we're going to say we're going to pick one of these 3 numbers to start with. Let's just go ahead and just at random pick number 1. So if we know that's one of our answers, one of our solutions, zeros, x-intercepts, whatever you want to call them, we can use that to break this polynomial down into smaller pieces, and those pieces will give us the other answers. So I'm going to start by breaking apart this polynomial of third degree by using synthetic division, and one of the answers that I already know I have, because the x-axis intercept one of these 3 was at 1. Okay? So I'm going to use my synthetic division. Multiply, add, multiply, add. This is supposed to be a 9, sorry. Add, there we go. Multiply, add, and sure enough, this is supposed to be a 0 remainder at the end, because we know this is a solution. So it should divide that factor, which is x minus 1, in evenly. So what does this mean? Well, what we just did is we divided a single degree polynomial into a third degree polynomial, which gives us an answer that must be a second degree polynomial. Now, yesterday we did a question just like this. We then factored and set each one of those equal to 0. And that gave us our answers that we were looking for. And of course, if you want to list all 3, the one that we cheated on, the first one, is 1. Okay? So, a third degree polynomial has 3 answers. Now keep that in mind. A fourth degree polynomial will have 4 answers, a fifth degree polynomial will have 5 answers, and so forth. So now we're going to talk a little bit about what kind of answers you could get. Okay? Remember, they're not always necessarily going to be real numbers. So, for number 2, again, I'm going to go back to my graphing calculator, and this time it's going to be x cubed plus x squared minus 5, x cubed plus x squared minus 5x minus 2. Okay, so we take a look at this one. Again, we've got some options. It looks like it crosses through. If I zoom in here. I don't think it's exactly at 0, and it doesn't look, this is like a whole number, so maybe a 2, positive 2. So I'm going to use positive 2 as my first kind of cheating answer. Okay, so I'm going to use synthetic division and positive 2 as my solution that I think I have from the graph. Okay, so multiply, add, multiply, add, multiply. Hey, sure enough, it was an answer. Because if it was a wrong number, then I wouldn't have gotten a 0 remainder. So sure enough, this works. All right, so basically what I just did is I divided a single degree polynomial degree into a third degree polynomial, which gives me a second degree polynomial. Now, here's the weird thing. This polynomial right here is not factorable. So if we try to break it into two binomials, it won't work. So our recourse then is the quadratic formula. So that's negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I substitute my numbers in here, I get, I'm going to put it up here, negative 3 plus or minus the square root of 3 squared minus 4 times 1 all over 2 times 1, which gives me negative 3 plus or minus 9 minus 4 over 2, or negative 3 plus or minus the square root of 5 over 2. Those are my last two answers. Again, this is a third degree polynomial, so we're going to have 3 answers. So my 3 answers are 2, 3 plus square root of negative 3 plus square root of 5 over 2, and negative 3 minus the square root of 5 over 2.